Hi everyone. So this is part two. We're gonna talk about gaming trees. So these are trees that try to analyze all positions in a particular game. Now, game is a very huge word. It covers a lot. But what we are talking about is a two-person game. So a game where one person, both persons are trying to achieve a goal, and of course they are kind of working against each other, and which means the following: that you can either the first person wins, the second person wins, or there could be a draw. So that's the normal setup with the game. But there is even more sophisticated games in which you actually try to make, for instance, say money or gain some other desirable quantities, points or something like that. And so that's not the same thing. It's not perhaps not to win the game, but to win the game at as much money as possible. And obviously, very often when two people compete, there is a loser and there's a winner. Not always the loser wants to admit that he lost, and there are very famous examples in our American history recently. But that means we're going to have to make a distinction between the two players from the start. And I'm going to introduce the favorite player, the one that we're going to think of as the good guy, and his name is Max. So Max will be our player that we're trying to make to win. It's not that we are trying to be biased or something like that. It's just we have to take a perspective. So we take the perspective of Max. So Max will be always our first, the player to go first. So, and another feature of this thing, well, there are a couple of things about games. So what kind of games we're thinking about? Thinking chess, checkers, tic-tac-toe, overall those things. There's a game that it's called NIM, I will explain the game, I will analyze it. There are other games that you can analyze. I'll start with a simple game, matches game. And very typical for these games is that they kind of have to end. There is only so many moves you can do until there's a decision. Some games like chess is technically they are not, because you could keep moving a piece like a horse back and forth, and the other guy could do the same thing, and so it would never end the game. Although there are judges that then would say, oh, you cannot do the same moves that many times, otherwise the game is called a draw. So that's why one has these things in chess. So in other cases like tic-tac-toe and so, you have to put in, you fill in a grid, and there's only that many slots available. So after the grid is filled, the game is over. And that's what we call finite games. That means at the end, there is either a winner or a loser, or there is a draw. And what one really likes are games where there is no draw, that there is a clear winner or a loser. Okay, and so let's focus on a game like that first. So what has this to do with trees, right? You might ask. So I'm going to describe a very easy game. So you have you have n matches. Let me put it in general. So n sticks and matches. I'll do it with matches. It's something that you can then do at home. You can put them there. And so what you can do is each player can take 2 or 3. So from this pile, you have to either 2 or 3. So you have this choice. Otherwise, if there's no choice, then there's no game, right? There has to be some choice. And so player loses if there's less than 2. If at his turn, his or her, sorry, we have to be we have to be gender unspecific, and the best way to do this is to use their. This is the new trend. Even although this is a singular, we use the plural there. They lose if at their turn too few messages, either 1 or 0. But I could change this later and say instead of taking 2 or 3, you can take 3 and 4, or can 3, 4, or 5, or something. You can put up here your own numbers you want. And so now the question is, Max, being the first guy to play, does he have a strategy to win? and is it lock, or how does it work? Now, this clear is game is a finite game, right? There's only so many matches you can take, and it will end in either a win or a lose of Max. Well, so Max will either win or lose. Now, Max is our first player, so it all comes down to, is there a strategy for Max to win, as he has to play first? Or is the other guy, we'll give him a name later, but for now I'm just gonna talk about Max. So let's look, where's the game tree now? I haven't still said trees are not there yet, right? So now let's bring in the Christmas trees. So, okay, let's say n is 7 here. Okay, so we start with the original situation, the startup situation is 7. I'm just the label of this root. And then I'm going to list all possible game results that result in Max's play. So Max can either take 2 or 3. Okay, so this is, I'm listing here, this is Max's level. You'll see we will alternate the levels between Max and his opponent. So when he's 7, he has 2 things. He can either take 2 and then there's 5 left, or he can take 3 and there's 4 left. So this is either 5 or 4. So the 3 is, an edge in the 3 means a valid play from the given situation to the new situation that is then handed over to the next player. So our next player we're going to call Min. I know this is not really a name, but you can see a little bit max and min, maximum and minimum. That's where this comes from. And this makes sense later, not now. Okay, so what we now have to do is do the same. Now it's Min's turn, and each of these situations, what can he do? Or what can they do? Remember? We don't know what the gender is. Okay, so we can take, well, Max, I guess, well, Max could be a female or a male, right? So we don't know. So he can, the next player, Min, can take 2 or 3. So that results in 3 or 2, right? Or in this situation, 2 and 1. Okay, and 1. So it's again Max's turn. Notice there's already one position in which he is lost. If he finds himself in this position, he loses because he cannot take. In any of these other positions, he actually will win, because let's look at what his options now are. So we have, if he takes 2 here, there's 1 left. If he takes 3 here, there's 0 left. If he takes 2 here, there's 0 left, and he cannot take 3. So there's the only possibility. The only possibility is same 0 here, and 1 is no longer a possibility. So this is the first time we have a full tree now. And what we notice is the leaves in a game tree. So in the game tree, or a gaming tree, or game tree, I don't know which way to write it. The gaming tree, the leaves are the final outcomes of the game. And they could be different. You see here the 2 outcomes that have 1 and 3 outcomes that have 0. And more importantly, they happen at different times. So you see that these losses happen when Min is playing, right? If it's now Min's turn, he loses in all these occasions. However, if we are in this Max's turn, then he loses in this occasion. From this, just analyzing, just common sense, makes clear what Max should do at the first one. He should avoid this branch, right? He should go into this branch. And once he is in this branch, it doesn't matter anymore what the other guy does. Then in his next move, he will make chop wood out of him. Okay? So this tells me, I hope you see it, right? This is the winning strategy. For Max will win the game, and Max will win the game by taking 2. And then no matter what the other guy does, it doesn't even matter anymore what he does. Let's see what happens if I change this n into, let's say, 8. Okay? So 8. So now we have the 2 possibilities are 6 and 5. This is Max. Now Min has several choices. In this case, there's 4 and 3, and here there is 3 and 2. In this case, so this is Max again. And what is min now? Min gets here a 2 or a 1. If he takes 2, there is a 1 left. If he takes 3, there's a 0 left. If he takes 2, there's a 1 left. If he takes 3, there's a 0 left. And here there's only one possibility, 0. The only place where min can still play is here. And that is, no, sorry, there's only one branch, right? He can only take a 0 here. Question, is this always a binary tree? No, you will see this might be much higher arity. It's not a full tree either necessarily. In this case it is, but it really depends a little bit on the type of game that you play. So that's different than coding trees. That were always binary trees, full binary trees. So what we see here is that most losing positions are again in min, but there's a losing position for Max so he has to be careful, right? So what should he do now? If Max decides to play this, go this way, then min wants to get into wants to steer him this way, right? So min says, okay, I'm going to do that. Now it's Max's turn again, but Max can counteract by doing this. If Max is not paying attention and does this, then min has him in his he will win. So far Max still wins. Let's see whether it gets better with or changes when we start at n is 9. So here is 9. The two possibilities are 7 and 6. So this is Max, this is min. I guess I should perhaps switch to lined paper, that makes it easier. So 5, 4, 4 and 3, this is Max again. Now we are back in min's territory, that is 3 or 2, right? Here this is 2 or 1. 2 or 1, and here there is 2 or 0, and now Max. So here is 3. What are we doing? 2. Yeah, so 1, either 1 or 0. Here there's only 0 possible, This is already a leaf, this is 0 possible, and this is only 0 possible. So now you see it's already a little bit more tricky, right? There are losing positions for min in these cases. Let me mark the leaves, because these are leaves are the losing positions, right? So here are the leaves. Perhaps use a different. A little bit bigger here, and make this a little bit bigger. So the leaves are this, and this. So whenever we have a leaf, you have lost, right? If you are offered a leaf, you have lost. Who do you think has now? So Max was starting here, right? So Max started at 9, but we could play the game this way and say, okay, instead of actually playing this game, I'm gonna offer you, Max, do you want to play first or second? Okay, we said Max will always play first, so we're gonna keep that, but I'm just saying, you could sell this game, so say, okay, for $5, if you win, you get $10, but for $5, it costs you $7 to be, let's say, well, I don't want to analyze this too much, but the question is it advantageous to be the first player, or actually are you sometimes better to be the second player? This is kind of getting a little bit trickier, right? So as I said, if Max can make it so that these occasions occur, then min will lose, right? If he finds himself in one of these occasions, he will lose. However, notice that there are many occasions in which Max loses. So how can we determine now who wins? And this is the whole thing. This is what the gaming tree is, not just what I did. We are now going to give weight to the games, and so we have the weight is called the is will be sorry. Okay, let me. I want to use the same terminology the book uses. Uh, well, value. Okay, we give values to each node. So in a game tree, so the next thing we're gonna do, or I'm gonna say game tree instead of gaming tree. I think that's a better word. Give values to vertices, and these values should represent the, what could say, chances that you win, or the amount of money that you win, because this is a win-lose. But you can also say, okay, the longer you hold out and you win, the more money you get. So even if you can win in 3 steps, if you can win in 5 steps, you get more money. So if we want to calculate that, we need values that are different than just win or lose. Okay, so give values to vertices. Now let's talk about a win-lose game. So there are only 2 outcomes. You either win or you lose. And this is always from Max's perspective. This is something you have to keep in mind. Max is the first player. So we always think of Max as the first player. And from Max's perspective, what is win? He either wins or he loses. Okay? This is win-lose. The other games that we will talk about are win-lose-draw games, or games where you get monetary value games. Okay, but now let's start with the win-lose game. This is the win-lose game. Okay, there's no draw. So what is the win-lose game? So since we're thinking about Max, a win for Max, we're gonna give value 1, and a lose you think 0. No, that will be the draw. So the lose will be -1. Okay. So what do we do? So we give values to the vertices, and starting with the leaves. So that's the first thing we're going to do. So let me do the leaves first. I do that in green because our green leaves are green. What value does a leaf get? Well, it depends on the level that it is. Look, if this leaf, if Max found himself in this situation, this is a loss for him. So the value here is -1, right? Because he is losing. So this gets value -1. And any of these leaves will get value -1 here, because he will lose if this happens. However, if he ends up in these situations, if the game ends in this situation, then he has won. So for him, these are winning positions. So this will be 1, 1, and 1. So we have now all the leaves have values. So now is the question, how do we going to calculate the values of the inner vertices? And this is the principle, the max-min principle. That's the reason that I call them max and min, maximum and minimum. If you are so this is level 0, 1, 2, 3, 4. Okay. Sorry, give me 1 sec here, because it's always something. Okay, so this is. Give me 1 sec here, guys. Sorry. I just want to double check something. Okay, so since we are going to a min, so let's try to calculate this. This is in the min level, and therefore we will calculate the value by taking the minimum of its children. Okay, so here we're taking the minimum of the children. Which is that? Well, both are min -1, so this will be -1. Why do we do this? Let's think about this. Well, let me move on a little bit, because then it will be even clearer here. Let's consider. I'm not going to do all of them yet because I want to show you something, and then we'll do everything. So we have now taken care of this one. What about this one? Well, if there's only one child, the min or max, it doesn't matter. It is always the same value as the child. If there's only one, there's only the same value, right? Minimum max. But this is now where it gets interesting. So here we see we have two vertices with different values, -1 and 1. Okay, so what value should we take here? Okay, this is what we will call, we are in the max situation. So this time, at this level, we take the max of the children. So when do we take the min? If we're on the min level. When do we take a max? If we're on the max level. Okay, so what does this now mean? The maximum of these two is 1, right? The -1 and 1, the maximum is 1. And see, that's we take a maximum because this could also be monetary amounts, $5 and $7. We always take the maximum, and the same for at the other levels, minimum. Now, why do we do this? Let's think about this situation. If max, why is this considered a winning position for max? Okay, it's a winning position for max because not if he plays this, because if he plays this, then min is gonna take, if he takes 2 away, min says, okay, I'm taking the other 2, and there you are. But this strategy is a winning strategy. If it takes 3 away, min has no recourse anymore. Now, this is still clear at this level, but now it gets interesting. We're gonna fill this up, and what do you think that we are after? Think about it. What do you think? The value at the root. That will tell me there's only one possibility here. The strategy is now clear. We take maximum minimums of numbers 1 and -1. The result will be either 1 or -1. So let's see. What is the result of this game for max? Okay, so we have to try to fill in everything. Let's start with this node. There's only a -1, so that's very easy there. I'm going to do the ones that are very easy because they have only one child. Those are these guys. Okay, I've done everything at the min level. Okay, now I'm on the max level. We are in the max level, right? So we take the maximum of the children, but the children have both -1, so this is still -1. So in other words, if max finds himself in this position, he is losing. He can lose. If the other guy plays min is smart, then he will lose. Of course, it doesn't mean that he loses because min cannot be paying attention, or he can play with his little brother of 7 years old, and the brother just do silly things without thinking. But if the min is a smart player, then max doesn't want to be in this position because min knows what to do. In fact, in this particular case, actually, your little brother would even win because no matter what you do, you lose. Anyways, so this level, what this one? We take the maximum of these two, right? We're on the max, so this will be a 1. So this is again a winning position. What do we do in the next one? -1, because both are negative. Oh no, sorry, -1, 1. Sorry, my mistake. So 1 and also 1 here, right? And okay. All right. So now this is min level, so we have to take the minimum. Okay, minimum of these two, -1 and 1, that is -1. This is a max level, a min level, minimum of 1, it's still 1. Okay? And then finally, we have to take the maximum. We are now, to calculate the value of the root, which is in level max, we have to take the maximum, that is 1. So this tells me max has a winning strategy. And how does it, so not only that tells us, but it also tells us what the strategy should be. Okay, let's follow this. At the beginning, max should always go to, since this is a maximum, at least one of his children has this value. So let's go to that child. Now, this is a winning strategy. The other, min, will play something, will either play this or that. Okay? Now, since this was a minimum, this means that both actually have to be 1s here. And you see that both are 1s. So if he's in this situation, what should he do? He should play the game, take the child with the value equal to 1. This is this child. So he should not take 2, he should take 3. And so he can counteract, in other words, this move by Min, he counteracts by this move. What does he have to do here? Well, same thing. This move. Okay, so if he pays attention, it doesn't matter what Min does, it goes this way. Okay, what about 10? I hope you see that it cannot be that Max always wins, right? How would that be? That seems to be, let's think about it. What happens in 10? So 10, 9, 8. So please stop the video and do this for yourself, but work it out, then you see whether you understood this. Oh, not 9 and 8 and 7, sorry. So this would be 6 and 5. This would be 5 and 4. So this is Max. This would be 4 and 3. This would be 3 and 2. Another 3 and 2. This is a very simple game, and I will do games where things are really much more complicated than this. So far, you could probably guess a little bit what's going on, but okay. So this was in Min game. So this can either be 2 or 1. This will end up as 1 or 0. 1 or 0. This can only be 0. This is 1 or 0. This can only be 0. This can only be 0. And this is already a leaf. So that is Max. And then finally Min, that is this guy, that is a 0. That's the only one left. So you can see here that the majority of the leaves, but that doesn't mean anything. It just kind of doesn't sound good, right? The majority of the leaves, in other words, the losing, remember, leaves are losing positions in this case, are in Max's level. There is one, there are 2 here in Min's level. So if Max wants to win, he has to steer either to this case or to this case. Okay, let's see what we get. We have calculated the values. Well, no, we haven't, but let's put them in. So what are the values now? Remember, if Min is in this position, this would actually be a win for Max. It's always from the perspective of Max. If Min is in this position, he can not take anything, he loses. So for Max, this is a win. That's why, so Max is the green guy. Let's make Max is the green guy. The values correspond to Max's perspective. Okay, so, but however, each of these are losses. Okay, because if he ends up in this level with either 1 or 0, so then he loses. And finally, this will be again a win. That's what we said. And now we have to do the min-max principle. If there's only one parent, we don't have to think, right? There's only one possibility. So here there's only one possibility. It has to be -1. This has to be -1. But here we have a choice. So, sorry, I'm talking about this here. So what's the value of this thing? Well, we're in a min level, so we have to take the minimum of the children. That is -1. This one, again, no choice because there's only one child. Again, we have to take the minimum, so this will be -1. We take the minimum, this will be -1. We take the minimum, this will also be -1. Although there is a 1 here, the minimum will be -1. Next level, we go to maximum. So from this time, I'm going to go this way now. I'm going to take max of the 2, but the max of 2 -1s is still -1. The max of -1. You see, it's getting really not good for... here the max is 1. So max has still hopefully one way of winning. That is if we can get to the rightmost branch there, basically. Okay? Okay. Next level, we have to take the minimum. So again, we're going to calculate this and this by taking the minimum of these values. That is -1. And this is where things get bad for max, right? Because we have to take the minimum, which will end up in a negative. So although the next level we take a max, we have to take the max of -1s, so this will -1. So max, I'm sorry, if your opponent is smart, you will lose. And he still has, what this tells, even if he knows that he's losing, he still can try to win. He knows there is only 2 ways he can win. That is by, but he has to make this decision. Should he try to steer the guy in this direction, or should I steer him in this direction? Okay. max you can choose. This is more dangerous because there's so many more losses that it can occur than this one, but this one might be too obvious. I don't know. Okay, so this is one of the games that that I want to discuss. I will discuss later a very important game, Nim, but I want to do. Okay, this. Yeah, that's okay. Then I don't have to write these lines anymore. Okay. So let me do tic-tac-toe. So tic-tac-toe. This is the English version of this word is called. This game is called. It's circles and X's, right? And in fact, that's why in my language we call it OXO, which was the name of a broth, a soup maker, but OXO. So what is the goal? Yeah, perhaps I should now change my paper into smaller case here. Okay, the game is we have a 3x3 grid, and you take terms. So again, X is going to be the max, X of max, right? And then the one that puts in the O's, that will be min. Okay, so you start, max starts and puts in an X. And then it's min's turn, and min can put his O there. Now what's the goal is to get 3 of the same, either horizontally, vertically, or even diagonally. Okay, so X says I'm going to put it here. And then if min doesn't pay attention, if min says, oh, okay, I see, I'm going to put it here, and then you're not going to see what I do. So max says, okay, I put my X here, and I win. So this is not a good play for min. So what should min have done? Min should have covered this hole. And by covering this hole, it now forces max to do something, because if max doesn't react to this thing and puts something here, min is going to make his row. So max has to put an X here. But this again puts min in a defensive position, because he's now to defend this position, so he has to put an O here. And this again is something that is bad for max, so max has to put an X here. And this, no, O says, oh, wait, this min, I call him O now, has to put a 0 there, but then max says, no, I put an X here. Result, draw. Because neither one succeeded and the game is finished. So this is a win, lose, draw game. And in fact, I don't want to analyze this. In this game, if both players know how to play, and this is why you play this with small children and not with adults. If you have played a lot of this game, you know that you can always get to a draw. If you play carefully, you always get a draw. But if you're not playing carefully, you could lose. Okay? And I want to give you a situation. Suppose, what I can now do is start modifying. So let's say, we can make a game tree of tic-tac-toe. And we start with an empty, so we could, the root would be the empty board, right? And this is Max's game. So there are now what? How many children will this have? Well, there are 9 possibilities that X puts his X. So we will have 9 children here. So 9 children. And they will all, and let me draw one of them. So one of the children will look like this. Let's say X put the one where we have an X there. But there are 9 different ones. And then those, now O has to play, and there are going to be, again, how many positions? 8 positions that, there is one less now. So we're going to have 8. So the 8 children. And for instance, let me draw one of them. That would be the X we have already, and then the O goes there, etc. And now there's 7. You see, this is an enormous tree actually already. So analyzing this game, you can do that, and if you do this using the technique that we described, and okay, yeah. So I should say this. Remember, win was 1, lose is -1, and now comes the draw that we will give value 0. And if we analyze this whole thing and calculate the game tree and the values of the game tree, and we get the value of the root, we will see that the value of the root is 0. Okay, sorry, don't confuse 0 with the O of the play, right? 0 is a value, which means that max, whatever max does, min can counter his actions and make sure that he doesn't lose. He's not going to win, but he can make necessarily, but he can make sure that he doesn't lose. In other words, get to a draw. Okay, so in this sense, it doesn't make sense to make this tree, but what we can do is we can say, okay, instead of playing this game on a full board, I can play on a set board already. So let's play the game of tic-tac-toe where the root, sorry, where this is the root. X, 0, X. Let me think a little bit. What was this? X, X, 0. Now, I have to be truthful to you. This is not a position that can ever occur in a tic-tac-toe game. Why not? Notice that if you play tic-tac-toe, at any time you start with one X and then one O. 2 X's, 2 O. 3 X's, 3 O's. What is the situation here? 4 X's, only 2 O's. That cannot be. Max has played 4 times and O has only played 2 times. It can only be one difference. So this is not a situation that can arise in a regular tic-tac-toe game, but doesn't mean that we cannot play the game. So we say, Max, your turn. Okay, so let's, okay, Max. So this is the root. Okay, I'm not going to draw the vertices, the nodes, the little bullets anymore. I'm just going to go to the possibilities. Now, it is Max's term, so an X will be added to this, and there are 3 remaining positions. So we'll have, so this, that's why I was trying to say, this is not necessarily a binary tree at all. Well, we saw it. This was actually, it started with 9 here. So what we have here, okay, so let's put in, oh, okay, let me do this way, sorry. I'm going to try to be smart. I don't know how that will work. I'm going to copy this guy. Okay, so no. Okay. I screwed it up. Sorry, guys. Why is this not? Copy. Okay, now finally. So what I want to do is each time say paste. And so do this here. Paste. Do this here. Oh, the whole thing came with. That's okay. Paste. Okay. Okay. Next time I have to be a little bit more careful with these extra lines here. Okay. Okay, so we have there's a little line fell off here. This is the original position, so let's put in the new position in a different color. I can put the X here. I could put the X. Oh, I should have moved this a little bit. Can I move this? No. Okay. Yeah, this is something I did not pay attention to, and now we'll get to the new. Okay, I hope you see it's this position, or you can put the X in this position. Okay. These are the valid plays that Max can make, and this is now it's min's term. Okay, so this is min, and min has to put an O. So let me not do this copy anymore because it doesn't work. So I'll just do it by hand. So we have X, X, O, 0, X, X. Well, they're not exactly the same height, but it's X, X, O, X, X. Well, perhaps I should do this. Let's see what I can still do. The paste image and then try to align it a little bit. Yeah, okay. Paste. Oh no, I have to do paste image. Okay. I see the difference between paste image and paste. Okay, that's this one. And then here, paste image. Okay, and do one more time here. Paste image. There we go. All right, so this, oh, shoot. Now we should do this. Something went wrong. I don't know why this guy started moving. Okay, so this is the situation. Then we had the previous one. We put an X here. This is where the X was here. And this was where the X was there. Okay. So now it's O's term. Let's do this in a. I don't know why that is in orange. I should have done this in green, right? Because Max was a green player. Oh, I'm so sorry. So let's do everything here in green. So green, 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 and let's make the O player a red guy. So now he has to put an O here. I can put an O there, or could put an O there. You can put an O there or an O there. You can put an O there or an O there. And you see now that the next play of Max is actually determined. There's nothing he can do anymore. He has to put in either X or O. He has to put in X. So the next one is always gonna be. But let's nonetheless do this. So wait, sorry. So this was Max. Again, Max term. He has to put an X, and he's basically gonna make each of these things. So I'm just gonna do this now. X, X, O, X, O, X, O, X, 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 O, 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 X, X. There's now only one child. Each has one child, right? And this would be X, O, X, X, O, X, O, X, X. Sorry, it's a little bit tedious, but believe me, if you have to do the whole tree, it would be way, way more tedious. Okay, so this would be X, O, X, X, O, X, O, X, X. The final outcome here would be X, X, O, X, O, X, O, X, X. Now this is min. Let's give values to these games here. There will be now three values, 1, -1, or 0. Again, we use green again because it is from Max's perspective. What is this? This is a win for O. So this is a -1 for Max. This is a win because of this one. Okay. What is this? This is a win for X. So this is a 1. What's the value of this one? Well, a win for X, a 1. What is this? A win for X, so a 1. A win for Max, a 1. And what is this? A loss, so -1. Okay. We go to the next level and we have to take maxima, but they're all just single children, so they just inherit it from, from their parents. So this is -1, 1, 1, 1, 1, and -1. And so in some sense, we could have, there was perhaps no need to draw this, we could have inferred this, but just to keep our algorithm straight and that we know where everything comes from. Okay, we go to the min level, so we're going to have to take the minimum of these two. So this is a -1, because the minimum of -1 and 1. This is a 1, because we have now 2 1s, and here again will be -1. Notice that this actually gives only 1 occasion for winning and 2 occasions for losing. Sounds bad, right? But luckily we are in the max level for the next one, and the value of this is the maximum of these 3 values, -1, 1, and -1. There were no draws in this one. Okay, there were no draws. I'll perhaps in an exercise or a quiz or something, I will do something where there are also draws. I thought this would lead to a draw, but I made a mistake actually. That's right, I realize now why. Anyways, so this is a 1. So this tells me Max will win, and it tells you also the strategy. And you see, the strategy is, he has to be careful. He cannot play this or cannot play this. He has to play this way to win. Okay? The reason that he cannot play either this one is kind of obvious, because if he doesn't cover this position here, then by putting a 0 here, O will win. Even if O is not paying attention, unfortunately, he still will win. Oh no, that's not true. No, sorry, I'm saying that. If O doesn't pay attention, then actually X will win. But at least, in other words, if you're playing to somebody that's not paying attention, you might win. But there is only one strategy for him to make sure that he always wins, and that is to play this. It's kind of obvious, this game. The game of tic-tac-toe is too simple to analyze actually with game trees. And therefore, I want to introduce our last game, and this is the game basically invented for these purposes. And that's the game of NIM. So the game of NIM, so it's written N-I-M. I actually haven't researched why it's called this way. Okay, it says here it's an archaic word for meaning to steal, NIM. it's in my language, in Dutch, it's comes from the same root, which means to take. So what is the goal? You start with a number of piles. So a number of piles of, let's say, coins, doesn't matter what, or matches, doesn't matter. It's a number of piles. And at any time, you can take as many from one single pile as you want, but at least one. So a move. What is a move? So yes, I haven't used that word in a precise way, but a move from a game is a valid move. The thing is exactly what these edges represent in the tree. It's a move from a given position to a new position. So what is a move? Take. So let me put it in. Perhaps it's better to say it in two. Pick a pile and throw out or take away, take away a number of coins out of this pile. And when I say a number, I mean a positive number. Of course, if we allow to zero drawing, then then people can keep drawing zero and then nothing happens. But since we are always drawing something, the number of piles will diminish, and it will get smaller. There will be less and less piles, and they will be smaller and smaller. And so pick a pile and take away the number of coins out of each pile. The win, or let's perhaps better. Sometimes it's easier to say what the loss is. So let me say what the loss is. So a loss is no coins left. Because you are supposed to pick a pile and there's no pile left. Okay? So that's a loss. Okay. So let's draw the tree for the following game. And I'm going to get myself a little bit a different paper. Let's go to this paper size. Yeah, I think that's a good size. Okay. So I'm going to start with 3 piles. The piles are 2, 2, 1. So the numbers here, each number represents the number of coins in each pile. Okay? So what are the valued moves? Let's think about this. So this is Max, right? So Max it's Max's turn. He's going to play, and he's going to do what? He can. If he picks the first pile, he can take away one of these. He has to take at least one. So he can take 1 or 2 away. So if he takes 1 away, the result will be 1, 2, 1. But since we do not care about the order of the piles, it doesn't matter where the piles are, right? Because after all, it just matters whether there is any pile left or not. I prefer to present my situation from decreasing to increasing, from increasing to decreasing order. So I'm going to write this as 2, 1, 1. Okay. Now, what he can do from the first pile, he can take both away. And what we have then is, well, there's 1 pile left. So he has, let's put this here. So let's put this here. Now, he can do the same with the second pile, but the results will, since the order of piles doesn't matter, it's either going to be this case or this case. Yeah? If he picks this pile, he takes 1 away, then he's in this situation. He picks 2 away, he's in this situation. Okay, and then finally, what can he do? He picks the last pile, but there's only one thing he can do, that is take that one element out. So the last one is 2, 2. Okay. So this is the situation now that Min has. This is what Min is getting, and now Min can say, okay, what I'll do. In the first, in this pile, the first pile I can take either 1 away or 2 away. 1 away will be 1, 1, 1. If I take 2 away, then I have these other 2 piles left. Okay. What else can I do? I can take in either of these 2 piles, there's only one thing I can do, that's take that away. So the other situation that I'm in is 2, 1. I hope you see that's the only other situation he can get. There's only, after his move, it's one of these 3 cases. If this is the position that he starts with, it's either one of these. What is the position here? Well, Let's think about it. If it takes 1 from the first, so perhaps I should start drawing a little bit of lines, because otherwise we don't know where everything comes from. It can take 1 away from the first pile, it can take 2 away from the first pile, or it can take 1 away from the last pile. Okay? What can he do here? He can take 1 away from the first pile, and then there's 2 left. He can do the same for the second pile. The result, oh, sorry, we said we're going to write this as 2, 1, right? So it's 2, 1. Or he can take one of the piles completely away, and then he's left with 2. Okay, so these are the only possibilities that Min has, depending on which situation he was offered. And now it's Max's turn again. So Max says, okay, in the 1-1 case, what can I do? In the 1-1 case, I cannot do much. I can only take 1 pile. You're only allowed to take out of 1 pile, right? So this situation, it is, once you have only ones left, there is not much play left. You can already see what the next play would be. The next play would be take 1 away, okay? And then the next play would be 0, right? And the same here, right? You can only take 1 away. In the next play, you can take only that away, and you get a 0. Okay, there's more interesting thing happen here. In the 2-1 case, you could take 1 out of the 2 pile, and then you're left with, let me go this way, 1-1. Or you could take the whole 2 pile away. You get 1. Or you could take the 1 pile away, and you get 2. Right? Okay. And notice after a while you should see that if you start with 2-1, this is the result. Well, you can copy this, right? Once you're sure that you did it correctly, so we can already say what happens in this case. We know in this case it will be 1-1, 1, or 2. Okay. 1-1s we already discussed. There's only this possibility and then a 0, and this is immediately a 0. What about the 2? There's still 2 possibilities. Because I can take both away and then there's 0, or I can take only 1 away and there's 1. Okay, so this is also the same here, so 0 and 1. Okay, so be careful, all this was in the min, this was min, this was max. I did already a couple of them because they were obvious what happens, and this is another one that I can do. This one is a, this is a 0, this is a 1. What else do we have? Yeah, okay, let's be, sorry, I'm running a little bit too fast. So this is a 1, the 1 gives me 0. The 2 is still 2 possibilities. This is either 0 or 1, okay. 0 is, of course, is 0. There's the leaves, what are the leaves going to be? A loss is no coins left. That means leaf is 0. That's the only, leaves should be 0. Otherwise there is something still left and you can take it away. In the previous game, since we had to take either 2 or 3 away, the leaves were 0s and 1s. Okay. All right. So here, what else do I? This. Okay. This one. This gives me 0, and the 2 is still 2 possibilities. 0 and 1, and this is 0. Right. This was for max, and then finally this is a 0. This is a 0. This is a 0. This is a 0. This is for min. That's the game 3. Okay. Now in the textbook they don't draw the 0 level. They say once there is 1 left, that's a losing position. That's a winning position. Sorry, that's a winning position. If there's 1 left, you win because when you can take that away, that 1, and the next guy is 0. But I prefer to present it a little bit more in its full detail. Okay. So where are we now? We were trying to calculate the value of the max, 1 or 0, minus 1 or 1, minus 1 or 1. This is again a win-lose situation, right? There's no draw here. Okay, so in the min, if min has a 0, then that means min will lose, right? If min is confronted with this boards or this situation, he's losing because he cannot draw anything. So these are 1s. This is the 1 value. Let me not write it there. I'll write the value underneath of it. 1, 1, 1, 1, 1. However, 0s in the max column will be losses for max, right? He shouldn't have that. So this is minus 1, 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 minus 1. So let me hold for a sec. In the previous cases, if you think long how hard, you probably saw the answer, right? You could kind of guess. Do you think you can guess it now? It gets too complicated, right? We haven't even analyzed the whole thing because remember now there's still some leaves left. The zeros are the leaves, right? So yeah, perhaps I should let me make them a little bit clearer that we see that these are the leaves. So this, what value would this leaf have? It's in the, when min has this means a win for max. So 1 here and 1 here. And then we had also these guys. I just wanna. Okay. I'm not drawing all the dots anymore, but let's just do this. Okay, let's calculate all the values now. And you have to be careful here. And so for that reason, I'm going to make a little ball, a bullet here, if I've calculated the value, so that I know that visually I see a little bit better what I've done. I have to take the maximum, but okay, if you have only one child, it doesn't really matter. So I'm taking maximums here. So this will be 1. This will be also 1. This will be a 1. This will be a 1, and that's it. Level 2. Now I'm taking mins. Okay, the min of this, but okay, that is only, oh, right. I was going to do this in a different color. Well, let's do this now in the next color, red. The colors are not just to make differences visual, okay? So this now is a minimum, but there's only one child. This is a minimum, there's only one child, so I don't have to think. Also only one child, that is was a 1, right? Okay. Then here we had only one child, so there's a -1. Here, what do you have? The minimum between -1 and 1, -1 and 1 is a -1. So this is a losing situation for max. This one is a -1, inherits from a child. These two have already. This is then also a -1. This is a 1. This is -1. Okay, the 2 again, it's a maximum of -1 and 1. Sorry, a minimum of -1. So this -1. This and then this one finally, that is it's what doesn't matter. It's the child, and for some reason there's this line missing. All right, next level. I do the levels in different colors. That's the only reason I'm using colors here. That's just to keep the levels a little bit apart. We're taking maxes again, but there's only one child, so I don't really have to think. -1, don't have to think. Okay, here, this is a real calculation here. I have to take the max of 1, -1, and -1, right? 1, -1, and -1, so the max of that is 1. That's good news, right? Okay, so here, it's one child, so I don't have to think. Here we have 2 children. Now we're taking the max. 0, the values are 1 and -1, the max is 1. So you see that the number, when you have one pile with 2 left, in this situation it's a good thing, in this situation it's a bad thing, from the perspective of max. Okay. So what is this here? I take the max of these 3, that is a 1. That's very good. I'm liking max's favors now, chances. What is happening here? Well, the max of 1 and -1 is a 1. Okay. Now we have to go a min. Mins are never good, right? They always diminish your options. So let's see where we are. What's the value of this guy? We're taking minimums. We have taken the minimum of these 3 values. 1, -1, and 1. Oh, damn, that is a -1. Okay, what about this guy? To take the minimum of -1, 1, and 1. Oh dear, that's not good, not good. It's not going good well here. The minimum of 1 and 1. That's a 1. Now, this is the last level. It's now max's level. Let's do max in, okay, max can be green again because max was always the green guy, right? So we take what? The maximum of -1, -1, and 1. -1, -1, 1. Luckily, that is 1. So Max can win this game, but he has to be very careful. Let's see what he has to do. So what is the path to victory here? He has to take, remember, always the value of the child. That the value that he has in 1, he has to go now to the child with 1. Now, we don't know what happens. Sorry, I should have done this in green, right? Because it is, after all, Max. is green, so let me do this in green here. So I'm green, this is what Max is going to do. Now, we don't know what min does. So I'm going to just say min picks randomly, says I'm going to do that. Now, Max has to be careful. He is in the winning position because he still has 1, but he can only choose a winning position in the next level. So he has to choose this child. So here is Max. He says, okay, if you do this, I'll do that. And now the game is kind of set, right? Because there's no much choice. Min has to play this. So Max says, aha, I'm going to take this away from you. And now Min says, oh, damn, everything is gone. All right, this is the game of Nim. And you see, this is a very simple situation. I will ask you to do more complicated situation. I definitely will do a quiz also on this one. And this is, I think I like this very much. And again, it's not very hard, but you have to keep your mind. It's the difference between max and min, winning and losing, and perhaps even draw. And I haven't even talked about the value here. Now, let's look at this particular case here, back up here. I'm going to do this very quickly. So I want to get rid of all the okay. I have to make this much smaller. Okay. So get this way. Okay, let's say the following. You say you win a win ending at 0 gives you $1. A win ending at 1 gives you $3. In other words, if you can play so that the losing player is confronted with a pile of 1, which is a losing position because he cannot take 2 or 3, you get $3. If he loses because he cannot draw anything, you get only $1. You already did? So I want to show you how you do this. So let's look at Max. These are the losing positions for Max. Don't forget, this is not good, Max. And what is he losing then, right? So losses are negatives. So what does this mean? What is the value for this one here? Well, if he loses, that means what is Min gonna? Min is gonna win $3. Yeah. So let's put it this way: whoever wins, the other guy has to pay for it. Okay. So in other words, this is for him minus $3. I'm not gonna write the dollars, whereas the zeros are only ones in value. Okay. Let's see what this means. Now, what about Min? If Min happens to have a 1, that means in this situation, if the game ends in this situation and it's Min's turn, he lost, he has to pay $3. $3, and here he only has to pay $1. Okay, so now let's calculate the values of the inner vertices. I'll do this in a different color that we can follow a little bit. No, sorry, do this in red. What about this guy? We have to take the minimum of minus 3 and 1, that is minus 3. The minimum, okay, there's only 1, this is 1, the minimum is only 1. That stays the same, right? That is calculated. The minimum is 1, the minimum is 1, and that's it. Okay, we are now in max territory. That means we're taking maxes. We take the max of these two, which is luckily still 1. The max of these two is 3. Oh, that's promising. The max of these two is 3, and the max of these two is 1. You see, different positions have now different values as we go through up. Now, let's see what happens at the next level. This is where it gets really interesting, right? We're getting closer and closer to Min. You could now perhaps predict a little bit, but I don't know whether you were able to predict it in the beginning. Honestly, I don't know, actually. So I want to look at this now. We take the minimum. The minimum here is 1, and the minimum here is 1. Oh, damn. So what does that mean for Max? Well, Max, you're going to take one of the maximum of these two, which is only $1. So he will win. We knew that. And winning is automatically $1, but he cannot force an error on the other guy where he pays more. Let's see whether this is the case in the 8th game. I didn't write the thing, so it is good. In the 8th game, this would be not good for Max. It would be cost him $3. But any of these, this would... no, that was only cost him $1. Sorry. Right? Yeah, that's only $1, right? It's when there's a 1 that is bad. So this is... but this is, in the min case, these are wins for him. So this is 3, this is 3, this is only 2, this is 3, only 1, sorry. Yeah, I got a little bit confused here. So 0 is $1, and 1 is $3, right? Okay, let me write that up, otherwise I'm getting confused. So this is a $3, this is $1, this is $1. Max. To calculate, there's still a few that we have to calculate here, so we don't know yet what this is. That is the minimum of the children, but there's only one child, and now everything is calculated. Okay, so we go to the next level, we'll do it in red again. We take the max of -1 and 3, that is 3. We take the max of 3 and 1, that is 3. We take the max of 3 and 1, that is 3. And take the max of 3 and 1, of 1, that is just 1. Good. We are now min territory. In min territory, we take minimums. The minimum of these two is 3. Aha, interesting. What's the minimum of these two? Well, that is 1. So what is now the max? Now, the last one, the root, max. We take the maximum of 3 and 1, that is 3. So, not only will Max win here, if he plays well, he can get $3. And how does he do that? Again, the same way, right? He has to choose the maximum value each time. So he chooses this. Now, the other guy it doesn't matter what he does, that's why we took the maximum here. Let's say he says, okay, I'm going to go this way. I think I'm going to win this way. Max says, no. I know what to do. I'm not going to go left. You think I'm going to take 2? I'm going to take 3, because now you have only 1 left. Granted, this is still too easy, right? So I want you to think about a match game. I'm going to put this in homework. So when I say homework for matches with this number means this game, and you can do the game either with win-lose or the game with payoff. And this is the payoff game. So I will set it in the homeworks, and I hope that you understand the terminology that I will use there when I say analyze these games, match games for n equals to blah, 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 and with win-lose or with payoffs. Okay? All right.